Hi, folks. We're back in statistics here with Mr. Robeson. Today we are going to look at normal distributions and the empirical rule. All right, so what is a normal distribution? So most of you have an idea of what a normal distribution is before because you've at least looked at or seen a bell curve. So a bell curve is a type of normal distribution. So it's a density curve. Right? Usually because we end up having an area under it of 1. So that means the areas stand for probabilities. All right, what's special about this, though, is that the mean will equal the median will equal the mode, which means that it is symmetric. So it is completely symmetric. All right, 50% of the data will be on each side of the mean or each side of the median here. All right, but that's normal for median. That's not normal for mean, though. All right. Most of the data will be here towards the middle. So if you look, like most of the data is in here, that's where the highest section is. And as we get farther out, the curve gets lower and lower, and we have less and less data as we go. All right. Almost all of it's going to be within 3 standard deviations of the mean. All right. So these curves on the right over here, they are normal distributions. So we've got a blue one, a green one, a red one, and a pink one. So which of these colors do you think has the greatest standard deviation, or which one is most spread out? All right, so spread has nothing to do with how tall it is. All right, in fact, the red one here is going to be the least spread out. The most spread out one is going to be the blue. So the blue has the greatest standard deviation. All right, 3 of these curves have the same mean. One of them has a different mean. Which one do you think has the different mean? All right, so for red and green and blue, they all have a mean right here at 0. But for pink, the mean is -2. So pink has a mean of -2. The other ones are all at 0. All right, which one do you think has the smallest standard deviation? I think I already said it. All right, the red one has a standard deviation that is the smallest because it is the narrowest, the thinnest one. I mean, it ends up being taller just because it has to have that area of 1 under it, and it ends up being much, much skinnier. Green would probably have the second biggest. All right, pink would have the third biggest, and red would have the least biggest. All right, notice they also mentioned variance up here. A couple of you were asking about variance last time. Variance is just standard deviation squared. If we square the standard deviation, that's our variance. All right, so these are all normal distributions, and here are their means and standard deviations. If you see the blue one has a standard deviation of 5, the other ones are all less than 1 or less. Yep, and the pink one is the one that has a different mean. All right, so when do normal distributions come up? So if we repeatedly measure the same thing, like in science, if we repeatedly measure like the weight of dachshunds, because I have a dachshund sitting at my feet, as long as they're the same type of dachshunds, they will all end up having a normal distribution with half of them below the mean, half of them above the mean, and some mean in the middle that has the highest. All right? IQ scores are also normally distributed. Heights are normally distributed. Heights of people, heights of animals, heights of almost any heights of trees. Blood pressure would be, like any sort of medical thing you measure, should be normally distributed. Repeated sampling statistics of the same question or measurement. So we're going to have a whole unit on this. But if we repeatedly take the same size sample from something and we're asking like the same question or like weighing the same thing and then finding the sample mean, those will end up making a normal distribution. All right, there's a whole unit on that coming up later, guys. So don't worry too much about that right now. But as long as we're repeatedly measuring the same thing or the same type of thing, that will end up being normally distributed. So here's an example, which is not likely normally distributed. So which one of these is not going to be normal? The number of red M&Ms in a standard bag over all bags of M&Ms, the height of all adult men in the USA, the current grades of all students in this AP statistics class, the weights of all adult male tree frogs in Brazil. So which one is not going to be normal? All right, so if we look at A, we should have some sort of normal distribution here with some sort of mean number of reds here And we should have most of them right around that mean. And then there'll be a few bags that have very few red and a few bags that have a lot of red. So this is likely normal. If we look at the heights of all adult men in the US, it's going to be somewhat similar to this. There's going to be some mean height. Then there's going to be most people are going to be pretty close to that mean height. And then there's going to be some people up here that are really tall, or NBA players, and some people down here that are really short. All right, so this should be normal. The current grades of all students in AP statistics. Well, let's see. If we put A here, B here, C here, D here, F here, what ends up happening is most of you have A's and B's at this point. So it ends up looking something like that. All right, so if we kind of turn that into a density curve, we go up and we come down, and then we have a tail off to the side here. All right, that's going to be skewed, and it's skewed to the right. So that is not normal. So our answer here, the one that's not normal, is C. Again, when we go down to D here, we're measuring the weights. That's the scientific thing from all male tree frogs. Those should also be normal with some sort of mean weight, with some really fat ones and some really small ones. All right, so there it is. All right, the other thing from class today is the empirical rule. So what ends up happening with normal distributions is we can figure out how much area or what percent of the data is within a certain number of standard deviations of the mean. So if we have this as our normal distribution and we have a mean right here, if we go down 1 standard deviation, so this would be the mean minus 1 standard deviation, and up 1 standard deviation, this would be the mean plus 1 standard deviation, we would end, this is not 10 by the way, it's 1 standard deviation. What the empirical rule says is that approximately 68% of the data for the curve is going to be within 1 standard deviation of the mean. All right. If we go out 2 standard deviations, drawing my other normal curve here, here's our mean, and let's say here is 2 standard deviations, so this would be the mean minus 2 standard deviations, and this would be the mean plus 2 standard deviations. Then this area in here represents 95% of all observed data. So 95% of the data is within 2 standard deviations. And finally, if we go out 1 more, we've got just about 100% of the data. My curves are never perfect here. But if we go out 3 standard deviations, so the mean minus 3 standard deviations and the mean plus 3 standard deviations, we end up with 99.7. Roughly 100% of the data is going to be within 3 standard deviations. All right, so now if something is more than 3 standard deviations away from the mean, you can call it an outlier. It actually can be even closer than that and still be an outlier. All right, that's not an official thing, but if you want to, you can do that. All right, so what ends up happening is if we look at all these sections like in between, we can break up that 68%. So this is 68 divided by 2. This is the 68 divided by, I said 8, divided by 2. And that gives us 34 on each side here. All right, if we go out 2 standard deviations on each side, then this whole part would be from here to roughly there would be 95%. If we divide that by 2 and then subtract the 34, we end up getting that this is 35 or 13.5 and this is 13.5. And then let's see, we've got 0.5 left over, or 0.15 left over on each side. The 99.7 subtracted from 100 gives us 0.3, and then we divide it by the 2 sections, gives us 0.15. All right, if you're worried about memorizing these numbers, you really don't have to memorize those numbers of this chart. If you have the charts memorized from here, that 68 is within 1 standard deviation, 95 within 2, 99.7 within 3, you're pretty good to go. All right, later on we'll have a way to actually derive these numbers, but right now, as long as if you know the first 2, the 68 within 1, 95 within 2, that's the big one, the 95 within 2. All right, so in a normal distribution, what percent of the data is between 2 standard deviations in each direction of the mean? So do you remember which one was 2 standard deviations? Hopefully you do. It's not 68. It's not impossible to tell if it's normal. Right? It is 95. So normal distribution, 95 is within 2 standard deviations. That's the big one to remember right there, guys. All right, if we want to, we can find all this stuff using the empirical rule. We're going to have an easier way to do this later on, so don't worry too much about this. So let's see, we've got the heights of women is normal. It says approximately normal, but normal is good enough. With a mean, all right, this is how you type it. When you type this mu, that's what it ends up looking like. I know it looks like a U. 64.5 inches and a standard deviation of 2.5. We will often write this way. This is an acceptable notation on the AP exam. This n means it's normal. The first number we write here is the mean. The second number is the standard deviation. So we can do that if we want. What percent of adult women have heights between 62 and 67 inches? Well, where's 62 and where's 67? So if we take a couple different ways we could do this, but if we just take our normal curve here that we're told we have, and we put 64.5 in the middle, and a standard deviation is 2.5. So if we go down 2.5, that brings us to 62. And if we go up 2.5, that brings us to 67. So that's one standard deviation each direction. So that is 68%. So it's 68%. Just by the empirical rule, this is one standard deviation down. And this is the mean plus one standard deviation. So one standard deviation up. What percent of adult women have heights less than 64.5? Well, 64.5 is the mean. That splits it in half because the mean equals the median here. So that means 50% are less than 64.5. And the last one here, what percent of adult women have heights less than 59.5 or greater than, so less than 59 or greater than 69.5? So let's go add another standard deviation here. So if we add another 2.5 here, that's 69.5. If we subtract another 2.5 here, that's 59.5. So that's 2 standard deviations. So remember, we said 2 standard deviations was 95%. So that means what's left over is 100% minus the 95%, which leaves us with 5% or 2.5% roughly on each side. All right, so that's how we can use the empirical rule for some shortcuts. All right, find the percent of IQ scores between 70 and 130, and we're given this, that IQ scores are N115. So this is normal, mean of 100, standard deviation of 15. All right, so here's our mean IQ score. If we go up 1 standard deviation, that's 115. If we go up 2 standard deviations, that's 130. If we go down 1 standard deviation, that is 85. If we go down 2 standard deviations, that's 70. So it looks like we've gone the mean minus 2 standard deviations to the mean plus 2 standard deviations. So down 2 and up 2 from the mean gives us 95%. So there it is, 95. All right, so that is a little bit about normal distributions, like how normal distributions look, and specifically the empirical rule. By the way, the empirical rule is also sometimes called the 68, 95, 99.7 rule. If you can remember that, then that is the empirical rule right there. All right, so turn in next time, we'll go over how to find actual areas and probabilities on the normal distribution.